Bandwidth and speed. More for your money. Free real-time snapshot and free weekly automatic backups. More security, less DDoS. More intelligence, AI assistance, and customer support. Get more of everything you need, pay less than you'd expect, and get your server online in minutes. Go to Hostinger.com and get more. Trusted by millions worldwide. Hostinger. 3, 2, online.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem. Check if number is a sum of power of threes. Very, very nice problem, at least in my opinion. I really like it. Short and sweet problem description, very clear examples. The solution is actually very easy to code up. Not necessarily trivial to understand it, but at least we get to spend our time doing interesting things, actually like thinking about a problem. So I'll be showing you two solutions to this one. One is kind of a more traditional solution involving like a brute force or more backtracking approach. And the second one is a bit more math or theory involved. To be honest, I thought this was just a backtracking problem, so I just coded up this one. I thought that's the one I was going to be recording for this video, and then I quickly looked at the other solutions, and it turned out there actually was a more optimal one, and as soon as I saw it, it made complete sense to me. So I hope it'll make sense to you by the end of this video. We're just given a number, let's say n equals 12. We want to know if this number can be represented as a sum of powers of 3, and they have to be distinct. So what do they mean by power of 3? Well, you have a number, 3 in this case, and we raise it to some power x. So we could start at 0. 3 to the power of 0 is 1. Any number to the power of 0 is 1. That's kind of like a base case. And then we have 3 to the power of 1. That's also very simple. It's just the number itself. Where let's say maybe we include this one, or maybe to recognize that actually is enough. And let's, for I, of course, at this point, we are at the I equals 1. Skip it, staying as 0. I'm mainly going to explore the path that actually leads us to the solution. So on this side, we are at the I equals 2 choice. So that's what this level of the tree tells us. And so our choice is if it's possible or not. So this is this path, but then we find that, okay, now our choice is 27. So you add that, we get to 37. You could skip that too, and then you could get to 10 here. And you might think, well, it's still possible for us along this path to reach 12, but actually, no, it's not. We have to somehow be able to detect that it's not possible, because we know that now our sums are always going to be larger than the original number itself. So we should also stop. Possible power, we're not going to have 10 trees, 10, it's probably not a huge deal. Track, I'm going to pass into and return true. It's usually better to put this case before the other one. Sometimes it doesn't matter, but in this case, it actually does. In my case, the other base case is going to be that we could simplify this down to n. That is huge. We are really only looking for the number 3 to the power of I, where it's either equal to n or greater than equal to n. So let's just say like approximately equal to n. So then we can just do a bit of math for the other one. Sometimes it doesn't matter, but in this case, it actually does. In my case, the other base case is going to be this. If current is bigger than n, of course, we would stop in that case. And of course, we would want to return false. But there's one other case we want to return false because we don't want infinite recursion in the event that there isn't a valid solution. In the event that we never return true, we want to return false in this case where 3 to the power of I has already exceeded n. Now, if that's not the case, then we can take this power and then try to add it. We can try the recursion. And before I do that, let me just show you how we're going to be calling our backtrack function. We're going to start, of course, at power 0, and our current sum is initially 0. We want to return the result of this function call. And now in the recursion, there's two cases. Either we include or we skip. I'll do this include case first, but I don't think it really matters which one you do first. I'll call backtrack, and we will move to the next power, I plus 1. And for us to ensure that we've included the current power, we can just take the current sum, add to it the current power, which is 3 to the power of I. So we can just return this if it's true. So let's say if this is true, let's return true. If it's not true, then we have to keep going. We have to keep doing the brute force. Let's try the other choice that we can make, which is skipping. So backtrack, I plus 1, and the current sum stays the same. Now, if this is true, we return true, otherwise we return false. We could handle that with an if statement, but it's easier just to return the result of this function call. So I believe this is the entire code unless I have like a typo or something. So let's try to run it. Yes, and as you can see here, it works and it's pretty efficient. But there's actually a more efficient solution. And it's possible that you can arrive at that solution on your own. I'm going to try to give you some hints right now, and then I'll just walk you through the solution. So let me kind of give you just a tiny bit of math background. It's going to be a little bit simple